Okay, welcome back. Just check my microphone. I don't know. Okay. So do I hear my own voice? I do hear that. It's okay. It seems okay. Uh, we do now. So I try to ask questions from AI, and I don't know why it's so difficult to make it understand that, there is a difference between the system that I used to design and a system that I want to design. So I'm trying to do that with Gemini, and I really don't see the hype there. So I'm gonna have to ask just simple questions. Like, how do we do? So for example, okay, hash map. How does the iteration for hash map? Okay, let's go there. Or for example, how does get work with the hash maps inside the SIG? Okay, value 42, value. I see. I did the correct thing, I guess. Here, I did a while. I set the step third to the end. One step. And then bucket and 0. End is a position, it's not an index. It's an index. So I think I would have to make this const p dot f to y or no, this is big. And then this is the position divided by t dot old map file size. Okay, and then we go here. I would call you index end, and to the bucket I'm gonna call you current. current it's int current int current and current. Okay, very good. Calculate the direction, the location. I don't need to do that. Wait, do I? Yeah, I need to do that. So this one should be less or equal. Okay, if it's not equal, I should put it not equal because it could be less or more. It depends on the steps. That could be -1 or 1. It could be 0, then this becomes a infinite loop. So I have to put and here. I have to say, for example, step 0 is not 0 and or you could just yeah, I can put everything here inside so that this condition doesn't have to be step 0 exactly, not 0. And then here I don't have to put this. Okay, very good. So I step by step get closer, one by one. I have to do this one more time when I get to there, right? No, because, yeah, okay, exactly. So I don't need to do the last one. The last one is definitely the corner, as far as I can. Okay. Yeah, the last one is definitely the corner. I can say that. Int current multiplied by the tile size. X now. I calculate the y. Get the y index. And then here I have the int current index, y index, and here there should be a value. And value is basically a tile. So if it's a wall, brick, the brick, I will have some int current x work with. Okay, very good. Now we do this similar thing here. Step 0. Is not equal to 0. I have a feeling this is really bad. I don't know why. I will have to check. Maybe there are some YouTube videos that explain this algorithm and I can just how is the tiling so far? Hi, how are you doing? So, I mean, I'm trying to make it work. So I don't exactly know what's the algorithm for raycasting in tiling system. I'm trying to make something work, but I don't think this is the correct one. Probably I'm gonna have to ask AI for help again, or to fix some of the details here and there. Or maybe I can just watch a video. I think there was a video that I saw some time ago. People were using C++ to do it. I might have to do with that. For now, let's try this. So I will have to do the same thing here. And current one is not equal to, and n1, then in current add step, and then here. Okay, so here we're gonna have to calculate x. To do that, I need the inverse of the direction, I guess. How do I do this? I have the direction. Is a vector. Okay, this doesn't make sense. I'm making a mistake here. Okay. I wish there was. Let me check. There was some. Okay. DDA algorithm. For tiling to the testing and tiled in DDA. So I believe that the voice you're not gonna hear it in the stream, but it's okay, I guess. I mean, I can show it. We can go through all of this one by one and see how things go there. So the video from 4 years ago. How would I know that? Okay, can I use this? Can I show this video in the stream or not? I don't know about the copyright stuff, so I guess I have to watch this and try to. Okay. Loaded feature. Okay, there is a web page. Loaded for G. Is there a link? Is there a link there? Oh yeah, they have put a link there that I can follow. Okay, I can try to show you what's going on. Okay, so the basic idea, they're explaining the basic idea. This is a tiling system. We're going to cast a ray in some direction, but we have to stop before a block solid. Okay, the infinite precision with this method and infinitely small step size, and thus infinite number of calculations would be needed. Pretty bad. Luckily, there is a better method that requires only very few calculations, yet will detect every wall. Okay. Oh yeah, I'm not showing the video because I don't know. So I didn't show the video and because I am not sure about the legality, like copyright stuff. So I don't have as much information, like which video can I show, YouTube video and stuff. I mean, okay, I can just tell you which video it is. I can put the link, I guess, inside the. Where can I put the? Yeah, it's this one. So I can put the link in chat, I guess. Yeah, if you want to check the video, they're explaining everything there. But I'm not gonna follow the video because I'm not sure. Like I think there's a limit on how much I can follow the video and stuff. Uh, I'm gonna try to show you instead the exact website that the video is based on. Like there's explanations in this web page. Position, direction, plane, and direction plane. Represents a 2D camera. Okay, I think I understand these things. So these are like player rotates, the camera has to rotate. I am not sure. So we don't do the camera here. Okay, so their world map is a 2D array. Very similar. I mean, I have a hash map of tiles, which are basically 0 and 1. Kinda. Like they have a tile type, which is either empty or solid. and then you can consider the solid ones 1 and for empty ones 0. I don't have 2's, for example, for my map. And then yeah, and I'm not using the 2D array. I am using a hash map for, yeah, each indices ij. I put some something there, some tile there, which is cool. It's okay. Are declared the position x and y represent the position vector of the player. Okay, position vector of the player is position. Yeah, I have a layer dot position. Okay. Direction x and y represent the direction of the player. I don't have a direction of the player. I'm casting ray to get the vision, so I'm doing it towards all the corners. Okay, so this is a little bit different use case, but we have to adapt the algorithm to our use case. For FPS corners, the rest of the main function and stuff, we don't care about these things. These are about camera. Calculate the ray direction and the position. So I have the direction, which is normalized, and I have a end position, which is the corner of some platform. These more variables are declared and calculated. These have relevance to the DDA algorithm. Map X and Y represent the current square of the map the ray is in. The ray position itself is a floating point number and contains both info about in which square of the map we are and where in this square we are. Okay, so basically index current, I have defined the int current for exactly that. Only the coordinate of the square. Where in that square we are. Okay. Map x and y. So in index currents are map x and y for me. So map x and y here are the same as the index current that I have in the code. Current square of the map that the ray is in. And the ray position itself is a floating point number and contains both info about in which square of the map we are. So square of the map, I don't really care about what is inside the square. I just want to see how you go through one square to another square. No, like, do I need to have this kind of thing? Okay, our coordinates of the square. Okay, there is the side dist x and side dist y are initially the distance the ray has to travel from its starting position to the first x side and the first y side. Later in the code, they will be incremented while steps are taken. Okay, so basically there's the side dist x. Side x dist is side dist x is basically the distance from the first side that we see in our direction with the ray on the horizontal side, and then in the y that would be, yeah, the vertical side. Okay, I see that. I've drawn everything here just to explain some of the details. Maybe this is a bit try to make this a bit bigger. But yeah, you can see that this I'm going to have okay. I'm going to have to calculate the probably remainder of the so if I calculate the position of the core, so if this point has a position, if I calculate the division of the position of this point by tile size, if I calculate the remainder, I will get some values that I can use for side dist calculation for the first one, basically. When deriving the delta dist x geometrically, you get with Pythagoras following. So for the blue triangle, one side has length 1, as it is exactly one cell, and the other has a length radier x, radier y over radier x, because it is exactly the amount of the units that the ray goes in the y direction when taking one step in the direction. For the green triangle, I see, okay. So delta dist x is just 1 plus ray direction to the power of 2 divided by ray direction x to the power of 2, and then we do a square root. Delta dist y is this thing, okay. So I have to calculate these two, but this can be simplified to some abstraction to ray direction. Okay, so ray direction x, and ray direction y. Wow, okay, I didn't know I could do that. Instead of calculating remainder, I can just do this. I don't know which one is faster. Is remainder faster or this one? I gotta go now. Have luck trying to out. Oh, thank you. Yeah, have a good day. Thank you for being here. Yeah. The radier is the length of the vector radier x. Radier y is that yeah, okay. You can indeed verify that example equals to this. However, we can use 1 instead of this because only the ratio between this matters for the detailed code that follows later below. So we get that, okay. So I have to normalize my direction. When I normalize it, things become easier. Okay, due to this, the delta dist and side dist values used in the code do not match the lengths shown in the picture above, but the relative size all still match. Thanks for spotting this simplification. Okay, I see. So what I need to do, okay, I normalize the direction. Now I need to calculate, I need to define const delta dist x. I underline now. Dist x, which is equal to apps Okay, I have to see first. So I have to make them 0 now. And then, okay, if, so these are variables. Oh no, I can just put some condition here. If there 0 is not 0, it is just 1 over there 0. Else it is 0. And then here I put this y. Okay. Okay, I have my delta distance thing, I guess, but I'm not showing it again in the stream for some reason. Forget this all the time. So let me, okay, now you can see that I have defined these two variables, delta d6 and delta dy. Direction is not, so this normalize of the direction. They're not 0, it's 1 over direction 0 and 1. We go back to here to the browser. You can see that here it's the same thing. Okay. Okay, due to this, delta dist and site dist values used here in the code do not match the length shown in the picture above, but the relative size still match. Okay. The DDI algorithm will always jump exactly one square each loop, either a square in x direction or a square in the y direction. If it has to go in the negative or positive x direction, and the negative or positive y direction will depend on the direction of the ray, and this fact will be stored in step x and step y. Those variables are always -1 or 1. Okay, so the length of ray from the current position to the next y is double, and then there's the length of ray from x or y side to the next x or y side. Okay. One over there. a double ball. Yeah, I don't know what is this variable. Okay, what direction step and hit? Was there a wall hit inside, north side, or east west wall hit? Okay. Division through zero is avoided by setting a very high value. I mean, it's normalized, right? The other one should be 1, this one should be 0. Java or JavaScript is not actually needed as it supports the 754 floating point standard, which gives the result infinity. Works correctly in the code below. However, some other languages such as Python disallow division through zero, so the more generic code that works everywhere is given above. Really chosen high enough number so that can be set to infinity if your programming language supports a sign. Now before the actual DDA can start, first the X and Y, the initial these things have to be calculated. Okay. And has a negative X component. Step is okay. So this is just basically the sign of array 0. That's how I define my step here, basically. So this is correct. It's just that yeah, this is okay, I guess. Very cool. Why it's not 0, so it has to be infinite. Let's put a really big value here. How do I do this? City that's math that is it I32? I32? They're infinite I32. I have to put them F, right? These are floating points. Okay. Again, I'm not showing the code to you. Sorry for that. Give me a second. Okay. So here, what I'm doing, I just okay. So this is delta dist x and delta dist y. They are either 1 over direction or they're just math infinity of floating point. And this is the sign of direction or step. We need also two other variables. I don't even know how to define them. Let me check now. Let's see how do they use them, how do they get their values in the algorithm here. Okay, so first step is sign is I've done it already. So here what it does, position x minus map x times delta dist x. Okay, so side test is the position of the player minus the map x times the delta dist x. And then slide okay, if it's positive, then this is plus 1 minus cos x times delta d. Same here, so I can do this a vectorial calculation. So that would be side dist x okay. I'm gonna just remove the underlines. I don't like underlines anyway. I'm not gonna make them dx and dy since we don't have dx dy work. Okay. Now I'm gonna do, I don't remember, should I do y or I think I should this side x, and then side x was equal to okay, let's go back to the happening. Oh, I think OBS has a bug or something because it doesn't show the browser for some reason. So weird. Okay. I don't understand why this is not working. Okay. I think I closed it. Okay, so So you can see clearly that I have to do the calculation side dist x is equal to, if it's positive, it should be, if it's negative, it should be position minus map x times delta dist x. Okay. Trying to understand why this is happening. So what was position x? Position x was, okay, position of player is position x and y. Basically, my position 0 and 1 vector for me. And then we do position minus index current times tile, I guess, tile size, times the delta dist x. I don't understand why do we do delta x multiplication by that. Is it the index, like position x? Is it like the absolute position, or is it index of the player position? Where it starts at the position of the player. I believe this is the absolute position. If that's an absolute position, then map x and map y are the absolute position of the tile that player is in it. Then, if that's the case, it should be on. So map x as is less than or equal to pos x in all the time. And map y is less than or equal to pos y all the time. If the ray direction is negative, for example, for x direction, for horizontal direction, that would mean that I do find what's the result of this and then multiply it. No, that would be exactly this. I don't understand why they multiply by this value. And then there is a position, and if it is positive, you do, that would be 1 minus, not 1, but the total value of the tile size minus position minus map x, right? What was this side dist again? I want to go back to it. Side dist, delta dist. Okay. Okay, this is more complicated than I thought. Okay, it's not just there's a delta A dist X and then there is a side dist. Delta dist X. Oh, yeah, okay, delta dist Y. And then there is a side dist X. And then there is side dist Y. Okay. And then I have to put here player position is start, corner position is the end, and then okay, the side dist x is I will define two more constants t1 equal to okay, my bird is calling a second. Okay, she stopped. Reason okay, we go back to the code. Let me show you the code. I will define two temporary variables t1 and t0, t1 and t2, I guess. And then this one is okay. What's the formula? Position of the player minus tilix. So that would be start minus tile x multiplied by yeah. Okay. Okay, start has 0 and 1, 0 and 1, and then const tx2 is equal to, what's the other formula? Or I can just can make them tx. So if something happens, this, else, else. Okay, and then here depends on the direction. If direction is negative, the first one. If the direction is negative, first one, else. Oops, sorry, it's not this one here. This is negative. Okay. And the second one is not 0, it's just tile x plus 1 minus cos x. X plus 1 minus start 0. Okay. Now I have to define what are tile x and y. So tile x is basically floor, city, that's math, that's floor, start of 0 divided by c dot row map dot tiles. I have to do this for tile y. 1. Okay. That would mean that the int current is not necessarily needed because I have tx and y. And then the side would be, yeah, this thing. Okay, this is exactly the same formula they use in the web page, I guess. I mean, I hope. Okay, now the actual DDA starts. It's the loop that increments the array with 1 square every time until a wall is hit. So each time either it jumps a square in x direction with step x or a square in y direction with step y. It always jumps one square at once. If the raised direction would be the x direction, the loop would only have to jump a square in x direction every time, because the array will never change its direction y direction. Look to the y direction, then every so many jumps in the x direction, the array will jump one square in the y direction. If the ray is exactly the y direction, it never has to jump in the x direction, etc. Okay, so it incremented with the delta with every jump in their direction, and some y get incremented step x and step y respectively. So, okay. I guess my steps should be multiplied. Okay. There is the sign of direction multiplied by c dot world map file size vector 2f. Otherwise, this wouldn't work. Because they are choosing to have so everything is normalized in their thing, and the positions are like between 0 and 1 inside the tile system, but I'm using Excel based thing, so I have to scale the whole algorithm to work with this somehow. Okay. File x is a start divided by that. Okay, start is okay. This should be multiplied by yeah. Okay, very good. Here we are calculating remainder. Multiplied by this. Okay. Okay, let's see. What's the next step? Oh, sorry again. You don't see what's going on. Okay, so here, so here it's map x, map y is just basically tile x and tile y. I have here, I can actually rename them map x, map y, map x, map y, and then this is map y, map x. Okay. It's just that I first calculate tx and ty, and then I put them inside the delta dist x. Now let's go back to the browser. Okay. So to perform the DDA, I have to go as long as there is no hit. So I have to define a function hit. I have to find define the boolean hit. Let me do that. I will just copy paste this code and then try to change it in a way. Okay, here we go. Paste. Okay. First, I have to define variable hit, which is false. As long as it is not hit, you continue. Now side dist x is side. Oh, sorry. Yeah, I'm coming. Okay, sorry. My birds were hungry. Okay, let's go back to the code. This one is side dist x, and this one is side dist y. Side dist x. Delta dist x. Okay, that's x, not x. Okay, so all of this can change. The map x can change this variable txty side dist change this variable as well. Okay, and then this is exactly set 0. Okay, so now side variable side is equal to is of type direct enum, one of these values, northwest, north, south, east, west. And then I will put it equal to north, south. Side, this means this is north, south, right? No, this is, I have to check this again in browser. Okay, here, what was side here? Side, north, south, or, okay, what is side here exactly? It is side. Okay, is it written here? No. Side is ooh, it's a weird one. Side here, exactly. So side equal to 0, does it? Okay. If the x side was hit, side is set to be 0. If y side is hit, we put it equal to 1. So yeah, it's in north south if it's 1. Go back to code. So the first value, this should be GW, and then I remove that. Equal to 0. This is basically GW. This is NS. This is 1. This is delta dist y. This is side dist y. And this is map y. Cool. Now here I'm checking our g.w map. That's file set get map. Oops. Give it some vector. Get map x, map y. And then I have to put it inside the, here I put tile. And then what I do is tile dot type, if it's wall, it's equal to true. Okay, very good. Okay, that's supposed to go on until we hit someplace. And we don't have, but this doesn't have any limitations, goes forever, right? Like an infinite algorithm. Infinite algorithm. By the way, okay. Okay, we get through this now. Okay, so the things that I was writing here, I could just remove them because they're not. I mean, this one is much more simpler than I'm trying to do. I don't need this segment stuff, segment collision. I don't need to do that. And then, okay, second. Okay, very cool. Now I have to return the hit point. Okay, go back to the code again. If radius x or radius y are 0, the division through 0 is avoided by setting it to a very high value. How? Okay, this is part I already passed. Okay. After the DDA is done, we have to calculate the distance of the ray to the wall. So that we can calculate how high the wall has to be drawn after this. What? I don't understand this. This is for, yeah, this is for, you know, yeah, I just want the collision points. I don't want what they're doing here. Okay, okay, how do we calculate? Okay, I think let me check the code again. I think, see what's going on here. So until the hit is not done, this is going to continue. Um, the corner. I mean, we have to check if we get to the position of the corner, right? And then if we are passing the position of the corner, we shouldn't go on. We should stop at the position of the corner, or so this algorithm has to stop with two conditions. Number one, to stopping conditions one, ray hits oh, okay, other three stopping conditions. One, ray hits a wall. Two, ray reaches the corner position. And then three, ray reaches the end of the map. No, yeah, corner position is the end. Okay. And then how do we, so this only checks for one, the other stopping condition is not being checked. I have to fix this, and then okay, I have to return the collision point. Return the collision point at the end. Okay, just remove this collision. It has to be defined somewhere. Yeah, that should be okay for now. Supposed to be a DDA algorithm, by the way. Test array from player position to a corner of a platform returns the collision point or the corner itself, or null if both have same, if layer and corner have the same position. Okay. So I have to fix this thing tomorrow. And then, yeah, I have to draw vision. I think the vision is the same. This drawing vision is not going to change. And then, yeah, that should be okay. If I can fix this by tomorrow and I can fix this, then I will check the collision probably around 1 week later. So I will see how much further I can take this, and then, as I said, Friday I will try to start a project either Friday or tomorrow night. I will see. I will try to start a project I might have to do it Friday evening. I will see. I will have to see my timing. I will put the messaging in my Discord. If you want to follow the announcements of the whole stream going live and stuff, or other you want to have some chat with some other people inside the community and stuff, there's a Discord channel you can join into. The link is in the description. Yeah. So I think that's it for today. Thank you for watching. I hope you're doing fine wherever you are. And have a good night and day. See you again. Hopefully tomorrow morning. I'm not sure about tomorrow morning, but I will update them. I will put it in Discord. I will see what happens. Yeah.